Hello everyone, today let's look at another combinatorics question, QP number 39, where we're dealing with the trinomial expansion instead of the binomial one, where we have x plus y plus z now to the 7th. So originally I was going to make part A where we count the number of terms, and then this would be part B, and then this would be part C, but I figured we have not done stars and bars yet, but if you wanted to calculate the number of terms here, you would use stars and bars. So for stars and bars, I'll either have a section later in this module, or I'll make a whole nother module called combinatorics 2, and we'll do stars and bars in there. But if we wanted to calculate the number of terms in here, we know that each term is some variation of this, where I, j, and k are greater than or equal to 0, and I plus j plus k sums up to 7. So using stars and bars, we know this is 9 choose 2, and it's going to be 36. That's just if you're interested. But now let's just actually get into solving the actual question. So for part A, we need to find the numerical value of the coefficient of this specific term. So for part A, this should be pretty simple. You know, we saw in 38 how we can do this with a binomial. We know that x plus y plus z to the 7th expanded is just like this, where the dot dot dots are the 4 in between. And we know that each resulting term that we add up is going to be one of the variables from here, one from here, and one all the way up to here. So for this specific term right here, I basically have 2 x's, 3 y's, and 2 z's, and I just need to calculate the number of permutations of these. So again, I have 7 factorial ways to permute 7 items, but these are going to be the same. All the y's are the same, so we need to divide out the 3 factorial permutations of the y's, the 2 factorial permutations of the x's, and the 2 factorial permutations of the z's. Again, just the basic multinomial setup, and this is going to be our coefficient. What does this actually equal? Well, 3 factorial is 6, so we can cancel out a 6 from the 7 factorial. We're going to have 7 times 5, and then we can cancel out these with the 4, so we're going to have times 3 times 2. So this is equal to 30. 30 times 7 is just 210, so we're going to have a coefficient of 210 on this term in the expansion. Now let's move on to part B. This is where it gets interesting. We want the sum of all the coefficients in this expansion. So how do we do this? Well, notice that any coefficients in this expansion are going to be of the form x to some power k, y to some power j, and z to some power n. Let's say these are just arbitrary integers. And then there's going to be some type of coefficient in front of this term. So basically, when we expand out x plus y plus z to the 7th, let's say, right, we have x plus y plus z to the 7th, that's just going to be a sum of some terms that look like this. So how exactly do we get the sum of all these coefficients? Well, let's just make x, y, and z all equal to 1, because then no matter what power we raise them to, it's going to be 1, right? And we're just going to end up summing all the coefficients. And that's exactly what the question is asking us to do. So let's say x equals 1, y equals 1, and z equals 1. So when we make these all 1, we're just getting the sum of the coefficients on this side of the equation. And on the other side, we have x plus y plus z to the 7th, right? These are both equal to each other. X plus y plus z, when they're all 1, is equal to 3. So it's going to be 3 to the 7th. So our final answer for part B is going to be 3 to the 7th. And also the generalized form of this identity right here is going to be really important in the next roadmap problem. So remember this setup and use it as a hint in the next one.